Hello and welcome to another video of Smart E Academia International. Today's topic is going to be on loans, annuities, and real interest rates. First of all, in order to understand loans, we need to know that what do you mean by loans. Usually, in a loan, when someone tries to get a loan from a bank, it gets a lump sum amount from the bank that he or she has to pay on regular monthly installments. So assume that someone gets a loan of X amount at t equals to 0 time, and the repayments are basically done on monthly basis, like that's first month, second month, third month, 4 month, fifth month, and so on and so forth, with equal amount of payments. I can call that, let's say, A. These are equal amount of payments that needs to be done until your full value of your loan is settled. So this particular thing would be your present value in this case. So the present value will be the lump sum amount that will be received by the person from the bank, and that will be positive. Positive because when someone receives some amount, we take it as positive, whereas these values that are monthly repayments are all negative because this is something that you are paying back to the bank. So remember this particular sign conventions. When you're receiving the amount, it's going to be positive. When you are going to pay the amount, it's going to be negative. So this is going to be really important as we go through this particular lecture. The process of paying back the loan in monthly repayments or equal repayments is something that we call amortization. And always remember, the interest is charged on the reducing balance, which means once, let's say, we are like, you get a loan from the bank at an interest rate of, let's say, 3.4% per annum, compound monthly, let's say. So what's going to happen? If once you've paid this, the next interest is going to be charged by subtracting the monthly payment from your original amount. So in simple words, as you're paying back your monthly payments, the interest is reducing regularly. So this is a very important concept. So in simple words, your interest paid, in this case, the interest paid to the bank would be the total repayments, that whatever you have done, minus the amount borrowed. So this is like a very simple way of understanding it. Now, having said that, we will not use any formula for this. In fact, we will be using financial calculators to calculate the repayments, as well as the present value, the future value, and so on and so forth. Because in this case, we know that we are paying back the amount, which means that interest will be reducing every year. So every month or every instant or whatever you have, if you're paying it on quarterly basis, then it will be reduced based on the quarter. The interest will be reduced based on the quarter. So we use the TVM, which is the time value of money solver, and in all the GDC graphing calculators or financial calculators, we have this particular function, which we will see using one of the graphing calculator when we move on to the questions. But before doing that, we need to understand some terminologies that you have to look in the calculator. So the calculator will always show you these kind of inputs that you have to put in order to generate your answer. First will be N, the second will be I%, the third will be PV, the fourth will be PMT, the fifth will be FV, the sixth would be P over Y, and the seventh would be C over Y. Now let's try to understand what each terminology or each variable is. N is basically, in simple words, the number of periods. The number of periods, if you want to understand, is basically the number of payments, that how many payments you are doing. For instance, you are paying on monthly basis and the loan will settle after 1 year. So the number of periods are 12 because there are 12 months in a year. Similarly, if you are paying monthly basis for 2 years, the number of periods would be 12. So this is how you basically calculate. I is simply the interest rate. And as it says here, percentage, you will put the percentage value in the calculator. You're not going to put the decimal value. Here you are going to put the percentage value. So this is really, really important in this case. PV, as we already said, it is the present value, the present value of the loan that you receive. And I said it's going to be positive because you're receiving the amount at t equals to 0, which means the time where the loan starts. PMT is basically your amortization. Amortization is basically the monthly payments, not monthly, I would say, the repayments, because sometimes in different questions you would see that the payments are not monthly, it might be quarterly or it might be yearly, depending upon your agreement with the bank. And we know this is always going to be negative. Why? Because you are paying this back to the bank, so it is cash outflow. FV is the future value. And this is a very important concept to understand. As I said, if we talk about the timeline of the loan, and let's see, we have the monthly repayments, let's say. Remember, this is the present value. Here you will have a future value. Here you will have a future value. Obviously, future value, that how much you are still owed. But remember, when the loan is settled, the future value becomes 0. Why? Because you have already settled your loan. So at the start, your future value is basically the present value, and then the future value can be calculated for each instance using the financial calculator. But once the loan is settled, you must know that the future value is 0 because all of the loan has been settled, so everything is 0. There is no money payable to the bank. Now, P over Y and C over Y. P over Y is basically payments per year. So this is simple as to how many payments you are doing, which is like almost equals to the number of payments. Okay, like how many payments you are doing per year. This is not equal to this, by the way. This is just per year, because maybe here you will have 3 years. So if you are doing monthly, this will be 12. If you are doing quarterly, this will be 4. If you're doing let's say annually, so this will be just 1, right? And C over Y is basically compounding per year. This is basically compounding per year. So this is also the same thing, and always remember both of this will have the same value. So if let's say you're doing monthly repayments, then your P over Y and C over Y is equals to 12. If you are doing, let's say, quarterly repayments, then P over Y equals to C over Y will be equals to 4. So this will depend upon the question of how many number of repayments you're doing. So this is a really important concept where you understand the that how you are going to use your financial calculators, and each of these terminologies will be vital to substitute values in your calculator and get your final results. Let's look into the first question, which says, Don takes out a personal loan of $12,000 to fund his wedding. He repays it over 5 years at a 6% per annum interest rate. Calculate the monthly repayments. Now, in order to do this, we're going to substitute this in the financial calculator, which I will tell you, but we need to understand the terminologies first. As I said, this N, I percent, then we have PV, then we have FV, then we have P over Y, and then C over Y. These are the inputs that you are going to do in your financial calculator. Now, first of all, what is going to be your N in this case? As I said, it's going to be the number of repayments. We know that monthly, it's monthly repayments, so 12 payments in 1 year, multiplied by 5 for the total of 5 years. So 12 times 5 is 60 number of repayments you're going to do. I in percentage is going to be 6, because if you see that your interest rate is 6%. Present value is the amount that you receive from the bank. This will be 12,000, and as I said, it's going to be positive because this is what you have received, so 12,000. Future value, because it's asking you that he will repay over 5 years, so after repayment, you know, the future value becomes 0, so we write 0 here. Now we need to know what is the PMT. Just missed here, there has to be a PMT here as well, and this is exactly that we need to find. What is the PMT? You will leave the section untouched. Whatever value there is doesn't matter, but just for convenience, try to put a 0 here so that you don't get confused with this, because it will automatically calculate this PMT, and you will see that once I substitute the values in the calculator. Now P over Y, as I said, it has to be the number of payments per year. So as it is monthly payments, we know there are going to be 12 payments per year, and we also know that the C over Y is also going to be 12 because these two are same. Now let's substitute these values in the calculator. Now this is a Casio FX9860 GIIST graphing calculator. So in order to do this, what I go to the TVM. Any calculator, whether it's DI Inspire or any other calculator, will have this function, TVM. We go in and we need to see the compound interest option. This is where we'll be performing our calculations. So in this case, it stays as function 2. So I'll go into the function 2. Now you see here, all these values are here if you notice. So as we know that our N is 60, I'm going to substitute 60 here. I percentage, the interest rate was 6%. The present value was 12,000 in positive. Now PMT, as I said, you need to put it 0 because this is what it will calculate for us at the end. And the future value, we know it's 0. The P over Y, we know it's 12 because there are 12 payments. And C over Y is also 12. Automatically, it has made it same. Now here it says what you want to calculate. We need to calculate the PMT, the amortization or the monthly repayments. And you see we get negative 231.99. Why it is negative? Because this is the amount that we are paying. So as found, our PMT was negative 231.9936, so on. But to make it in proper currency format, our PMT will be negative 231.99, which means that our monthly repayments are simply $231.99. The negative sign shows that this is something that you're paying. Now the B part says, what are the total repayments? The total repayments formula that we calculated was monthly repayments. In this case, it's going to be monthly repayments multiplied by the number of payments. This is the simple total repayments formula. So we are paying $231.99 per month for 5 years. So we know that 5 years is 60 months as calculated as N. So just multiply and we see we get $13919.40. These are your total repayments that you have done. And the C part, it says what is the interest charged. The formula for interest we wrote was that what the total repayments minus the amount borrowed. So in this case, Don has given the total repayments as 13919.40. The amount borrowed was 12,000. So basically the interest he paid on the loan was $1919.40 over the span of 5 years. Now let's look at the second question. It says Peter takes out a loan of £20,000 to renovate his home. He agrees to repay the loan over 4 years. So this is the loan amount and agrees to pay over 4 years at 8.25% per annum. interest compounded monthly. Find the Peter's monthly repayments. This is absolutely same method that we have followed. So our n is going to be the n, and I'll write the same things again: n I percentage, present value, PMT, future value, P over y, and C over y. So we know that it's going to be monthly repayments. So 12 months in a year multiplied by how many years? We have 4 years. 4. This gives us 48. I percentage is 8.25. Remember to write in percentage, and do not worry about whether it's compound monthly or yearly, because this will be same with whatever repayment you're finding. So both will have the same units. Present value again is going to be 20,000, which is being received by Peter from the bank, and it's going to be positive because it is cash inflow. PMT, again, the amortization or the monthly repayments. This is what we need to find, and as discussed, it needs to be 0. The future value is going to be 0 as well because it has been repaid after 4 years. P over y is going to be 12 because it's monthly repayments. Similarly, C over y will also be 12. Now let's try to put these things in the calculator and see what do we get. Now here, this is what we have found from the previous question. So we need to exit this and just change our values from here. So in this case, n is now 48. Your interest is 8.25. The present value now is 20,000. Your PMT is something that you have to find. I'll just put it 0. Future value is 0, and P over y and C over y are 12. Now we need to calculate the PMT again. I'll just go here, and now I get a PMT or monthly repayments of $490.61. So as we saw, our monthly repayments using the TVM calculator was negative 490.61. So means our monthly repayments was $490.61. Now the B part says, what is the outstanding balance on the loan after 1 year? Now, for instance, this is our timeline, and this is my year 0, and I know that Peter borrowed $20,000 at year 0. It has been paying equal monthly repayments, 12 monthly repayments, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, another 12, and each repayment we know was for $490.61 every month. It's paying, Peter is paying. Now he wants to find that after year 1, what is going to be the future value of my loan, the outstanding. So when we say outstanding balance, we don't just subtract this, because we know that the time value of money has changed. The value of 20,000 today, let's say, is not going to be same as the value of 20,000 after 1 year. So there is a proper algorithm, proper formula to calculate this. What we call this discounting, and we have to discount we can't just find by just subtracting all of these repayments from this, and we say that this is because there is interest, there is discounting, and like lots of things involved in this. So we have to use our financial calculator to get to this particular future value. So let's try to see what are the terminologies we need to change. So again, we have n, I percentage, we have present value, we have future PMT, we have future value, we have P over y and C over y. And in this case, it's going to be 12. Why? Because we are just finding for 1 year now. This is important. So this is going to be 12 because we are just calculating for 1 year. Interest rate is going to be the same, which is 8.25. Your present value is also going to be the same, which is 20,000. Your PMT amortization, it's going to be from the A part because you've already calculated how much monthly repayments you're doing. And remember, it has to be negative, very important, because it's going outwards. So 490.61. Future value is something we need to find. So we'll just put it 0 and we can see what is the future value. And P over y and C over y are still going to be 12 because they're monthly. So let's see how we can calculate our future value or outstanding balance after that. As you can see, this is what we have found from our A part, and it is already mentioned here. The calculator has already substituted the values here. So n in this case now will become 12 as discussed because we are calculating for 1 year. This will be the same interest rate. Present value will also be the same, and PMT will be 490.61 as calculated, but we can just write it for our convenience. It's what in currency form, so 490.61 rounded to 2 decimal places. Future value is something we need to calculate. Everything remains the same, P over y and C over y. Now we're not calculating PMT, we're calculating the future value. So we'll go for future value, and this is the future value. Now why is it negative? It is negative because it is still payable. It is something that needs to be paid back. So this is the future value or the outstanding balance of the loan after 1 year. So as discussed, as found from the calculator, the future value is negative 15598.72 pounds. So which means that the outstanding balance after 1 year is going to be $15598.72. Our next topic is on annuities, and to understand annuities, it is reverse of loans. In annuities, what happened? That you invest a particular amount, let's say X amount, and every month you get you withdraw, because once you invest in the bank, it gives you an interest, a profit on that particular amount, and every month you withdraw monthly withdrawals. The same way paying back monthly on regular payments, this is monthly withdrawals. This is an annuity. Okay, annuity is for a certain period of time. What is perpetuity? Contrast to this, it is for infinite amount of time, like an investment that will give you return infinitely. That's perpetuity. And this is also a word used in English literature for something that is continuing forever. Similarly, annuity is something that's for a particular period of time, and it gives you profits that you can withdraw on monthly basis, yearly basis, or quarterly basis, depending upon your convenience. So this is what an annuity is. So whatever you are investing, again, is going to be the present value, but in this case, this present value is going to be negative because you are giving this amount or investing this amount. It is something, a cash outflow from your perspective. Whereas all the annuities, all the regular withdrawals are going to be positive because this is something that you're receiving over the course of regular withdrawals. And after some times, the future value, once all of your annuity is completed, you have collected all of your profit as well as your principal amount, your future value becomes zero. And this is where the annuity is concluded. So this is the same way, a same perspective, a same logic, but in reverse for loans. Similarly, calculating withdrawals will still use the same thing, which is the TVM solver in the graphing calculator or the financial calculator. And the terminologies all are going to be same. Our N, we know it's going to be the number of periods. Our I is going to be your interest rate, that what you're going to receive as a profit. Remember, same in percentage. PV is going to be same thing, the present value. PMT in this case is going to be withdrawals, not repayments. And what's going to happen here, the present value is going to be negative and withdrawals are going to be positive. That's going to be the major difference in this. Again, FV is going to be our future value, and P over Y and C over Y are the same things, which are payments per year and compoundings per year. The same logic that we have used in our loans example. Now let's try to see some of the questions that we need to solve. The first question says, Sue has achieved her target of 700,000 in her saving funds for her retirement at age 55. She rolls the money into an annuity account earning 4.85% per annum compound monthly. How long will Sue's money last if she withdraws $4,000 per month? Now, what you're looking to find in the A part is that what Sue has done, that she has invested 700,000, which means it's going to be negative. This is the present value of her investment. And every month, on a regular basis, she is withdrawing $4,000 every month on regular basis. What you need to find that how long will Sue's money last if she withdraws this, which means when will her future value become zero? Means how many months you are going to basically, or how many payments, or in simple words, how many withdrawals she can make in simple words. So if you can understand number of withdrawals was what was N. So this is what you need to find in this case, that how many withdrawals she can make in this. So N, as I said, was the number of repayments for the previous loan example. In this case, N will be the number of withdrawals. I is going to be the interest rate, the profit rate in this case, which is 4.85. The present value of the investment is going to be negative 700,000 because it is something that's cash outflow. The PMT, which is the monthly repayments, is going to be positive 4,000 because it is something that you're receiving, so is receiving every month. Future value is going to be zero because we need to find the time and how many repayments our future value will be zero, means you will receive all of our profit and the principal. P over Y and C over Y will both be 12 because it's monthly repayments. Now let's try to substitute these values in the calculator and see what answer we get. Now in order to find N, I just substitute the 0 because this is what I need to find and it will be calculated from my graphing calculator. The interest rate is going to be 4.85. The present value is going to be negative 700,000. You see, it's opposite to what we did for loans. The monthly withdrawal is going to be positive 4,000 because it's being received from Sue, by Sue. Future value is going to be 0 because this is where we need to find when will our whole annuity will run out. And P over Y and C over Y is going to be 12. So let's try to find N. N in this case is 304.59. Remember, the units of this is going to be months because we are doing monthly repayments, and this will be calculated by here because P over Y, payments per year, is 12. So means this is per month. So the N, whatever we have found, is months, 304.59 months. So as found, our N was equals to 304.59 and so on and so forth. So basically, you're getting 304.59 months. In order to convert this into years, we know we need to just divide this by 12 and we get 25.3825. So we know that we have 25 years, and the decimal I can convert into months, like 0.3825. We know this is in years, so multiply by 12, and this is approximately 4.6 months. So if I want to round this off, you can say that 25 years and 5 months is the time approximately that she will run out. Means between 4th and 5th month, she's going to run out of her investment if she withdraws $4,000 per month. In the B part, it says, if Sue wants her money to last 30 years, How can she afford to withdraw per month? Now, see, basically, these are all the variables. So whatever question you get, you are supposed to find one of the variables, and the others you have to guess that what will be the values for that. So this is all about financial applications. That's what you need to do. So if we see here in the B part, so again we have N, we have I, we have present value, we have PMT, we have future value, we have P over Y, and we have C over Y. Now, what it's saying that she needs her investment to last 30 years. So and plus making monthly withdrawals. So 12 withdrawals a year multiplied by 30. So this would give you 360 months. So she wants her investment to last 360 months. The interest rate is going to be same, 4.85. The initial investment present value is still going to be same, 700,000. Now PMT, or the withdrawal, is something we need to find. That based on these values, how much withdrawal per month she can afford. The future value again is going to be 0 because we want our investment to run out after 30 years. And P over Y and C over Y is still going to be 12. Let's try to put this in the calculator and see what answer we get. Now let's substitute the values here. Now N is going to be 360. So 360 months is what she needs her investment to last. Interest rate is going to be same. Present value is going to be same. Withdrawal is something we need to do, so I'll put it 0. This is what we need to find. Future value is 0, and all other P over Y and C over Y is 12. So we need to find the monthly withdrawals. So this is what it says. So in order her investment to last 30 years, she can only withdraw $3,693.84 every month. So as found from the calculator, her PMT is basically $3693.84, which means, and this is positive. Why? Because this is what she gets. So she can withdraw $3,693.84 if she wants her investment to last 30 years. Now our final topic is real value of investments, or real interest rate. This logic is relevant when you have inflation as well accounted in your calculations. So far, what we have done, we have not included inflation aspect in our calculations, and this is very important because if there is inflation, then interest rate is not what it basically seems to be. So in economics, or in financial accounting, or in financial sector, we use two different terminologies for each value. We have nominal and real. Nominal is something that seems to be, like, let's say if I say that inflation rate is 10% and income rise is also 10%. Now a person might think that his nominal income has risen by 10%, but he has not realized that the inflation has also risen by 10%, which is basically cutting off its rise in income. So the real income is always found by accounting the interest rate into the calculations. Similarly, when we are talking about the value of investments, when we are investing in certain project, we need to account for inflation to see what is the real value of our investments. So first of all, we need to know that what is the real interest rate. The real interest rate is calculated by this formula: 1 plus nominal interest rate over 1 plus inflation rate bracket minus 1. So this is your real interest rate. Remember, the nominal interest rate and inflation rate should be in decimal form, and your real interest rate you will also get in decimal form, and you need to convert this into your real interest rate. For instance, I say my interest rate from the bank is 5%, whereas the inflation in the country is 3%. So I might think that my investment will rise by this particular interest rate, but this is not the case. Your real interest rate is basically 1 plus the nominal interest rate was 0.05 over 1 plus the inflation rate 0.03 minus 1. And if you calculate this, you get 0.0194. Multiplying this with 100 to convert it to percentage, you get 1.94%. So this is your real interest rate. Similarly, once you have found the real interest rate by accounting the inflation rate, you can find the real value of investment as the value of investment that we have found without the inflation rate, 1 plus inflation rate power n. Remember, n is same the number of periods that we have been calculating for our previous questions. So these two formulas are really, really important in order to understand or accounting the inflation rate. So this particular formula gives us the real value of investment, and this particular formula gives us the real interest rate. Now let's look at the questions. Cassie made an initial investment of 2,000 euros into a saving account and followed it with regular deposits of 500 euros per quarter. The account pays 1.2% interest per quarter, and inflation rate is 0.3% per quarter. Explain why the real real interest rate is approximately 0.9% per quarter. So we know, first of all, let's do the A part because this is fairly simple. In the A part, you need to say that why the real interest rate is not 1.2%. So we need to use the formula that we did. Real interest rate equals to 1 plus nominal interest rate over 1 plus inflation rate minus 1. So just substituting the values, 1 plus our interest rate is 0.012 in decimal form over 1 plus 0.003 is the inflation rate, and minus 1. What you get is 0.0089, and multiplying with 100 you get 0.89%, which is approximately 0.9%. This means that your real interest rate is 0.9%. And why it is low? Because we have incorporated our inflation rate as well, because it will bring the inflation rate in interest rate down. Secondly, in the B part says find the real value of Cassie's investment in 5 years. Now, here, if you notice, how is she investing? This is a very important thing. So this is the present value, or year 0. She's investing 2,000 euros. So we know that once you're investing, initial investment, present value is going to be negative 2,000. So one thing, this is clear. Secondly, she is further investing every quarter. You see, every quarter she's further investing 500 euros. So minus 500, because the cash is, again, she's not withdrawing anything. Now, this is really important, right? It's not an annuity question. It's something she's just investing it in order to get a particular return after some years. So negative 500 euros every month. Okay, very good. So this is going to be your PMT. It's going to be negative 500. Now you need to find the real value of investment. So first of all, you find the future value of the investment first, the nominal one, using our graphic calculator, and then we will see in the formula how we can discount it using the inflation rate. Now let's see we have N, we have I percentage, we have present value, we have PMT, we have P over Y, and C over Y. Now N in this case, this is really important. We know it's going to be 5 years, but what she's doing, regular deposits per quarter. So we know there are 4 quarters in 1 year, and if you see this is really important. Per quarter, inflation per quarter, interest rate per quarter, everything has the same units, right? So this is going to be 4 quarters in 1 year, multiplied by how many years she's looking for? 5, multiplied by 5. So N is going to be 20. So remember this, that N is 20. These are the number of periods. I is going to be the interest rate, which is 1.2. We're not going to put the real interest rate yet, because here we'll use the nominal one, and then we will discount it using inflation. So don't confuse this. Here you will put the nominal interest rate. Present value, as I said, is going to be negative 2,000. And PMT, which is regular payments, is negative 500 because she's paying. So again, it's cash outflow. P over Y will be 4 in this case because there are 4 quarters in a year. So 4, not 12, because previously we were doing 12 like monthly. And C over Y is going to be the same. Let's try to see what answer do we get for this. So if we see, our N should be 20 in this case. Our I should be 1.2%. Our present value should be negative 2,000. Our PMT should be negative 500. Future value is what we need to find, so I'll keep it as 0. And this will be 4 because there are 4 quarters in a year, and you can see automatically C over Y will turn out to be 4. So we need to find the future value. The future value turns out to be 12413.68. So 12,413.68 euros. This is the nominal future value of the investment after 5 years. So we have found the future value, or the value of the investment after 5 years, which was 12413.68 euros. Now, why is it positive? Because this is something that will be the assets for Cassie, which means this is what she's due. So that will be positive. In case of the loan, future value, it was negative because that was payable. This is receivable. So payables are negative, receivables are positive. Now, if you notice in the question, it says that we need to find the real value of Cassie's investment. And as I said, the real value of investment was basically the nominal investment value over 1 plus inflation rate power n. So the nominal value is 12413.68. The inflation rate is, as you can see, is 0.3%, which is 0.003. Power n is the same thing as this, the number of periods. So this is going to be 20. And if you substitute this in, you would see that you get 11691.81 euros. So this is the real value of investment, which is clearly less than the nominal value, because of the inflation rate. So always remember, the real value will always be less than the nominal value because the inflation is always rising. The last question is about a bank loan with a bit of complexity, so that we can understand our topic in depth and see how we can use our calculator to more effectiveness. So it says Oscar decides to start a new business venture, which involves taking out a bank loan. The bank charges an interest rate of 6.55 per annum compound quarterly. So we know it's quarterly. His quarterly repayments are this. So this is what the bank has told him to repay every quarter, and must be paid over 8 years. So everything is quite simply laid forward in front of you. It says how much did Oscar borrow? So means you need to find, so if I wanted to do this in terms of the timeline, we know that every month Oscar is paying this much amount, $933.62 negative. It's paying every month. We don't know that how much Oscar borrowed. But we know that the future value will run out to be 0 after 8 years. So this is what we need to find the present value. So again, n is, sorry, these are the quarters, not months, right? So n, I percentage, PV, PMT, FV, P over Y, and C over Y. Now, n in this case is going to be 4 quarters because it's quarterly payments. We know there are 4 quarters in a year, multiplied by 8 years because we wanted to finish in 8 years, repaid over 8 years. So the answer will be 32. Interest rate is going to be 6.55 as mentioned. Present value, something we need to find. We'll keep it 0 in our calculations, in our calculator. PMT is the regular repayments because it's being repaid. Cash outflows will be negative 933.62. The future value is 0 because the investment, the loan expires after 8 years, settled completely. P over Y is going to be 4 and C over Y is going to be 4 because of the quarterly repayment. Now let's try to find how we can find the present value. So as you can see, our n is going to be, if I go up, our n is going to be 32 because of 32 repayments. Interest rate is going to be 6.55. My present value is what we need to find. I'll keep it 0. My regular repayments are negative 933.62. You really need to keep this sign conventions absolutely spot on, because if you mess up with this, your answers will get messed up. Future value is 0 because it's being settled, and P over Y and C over Y is 4 because of the quarterly repayments. So let's try to find the present value. But the present value is 23110.12. So the present value is found as $23110.12. So this is the present value, and why it is positive, it's because this is something that Oscar has borrowed from the bank. So this is cash inflow. So this is the A part, which means how much Oscar borrowed. Now let's see the B part says how much interest will he pay over 8 years time. So in the B part, you need to find that how much interest he would pay, and this is pretty straightforward. Interest is basically the quarterly repayments that every quarter is doing times number of quarters that you have to pay. So we know that he's paying 933.62 every quarter, and how many quarters are there? We know that's 4 times 8, which is same as this value, because we are trying to find that how many repayments he's doing. So every month he's doing 933.62 multiplied by 32, which will give you $6765.72. So this is the interest that Oscar is paying on his bank loan of $23,110.12 for 8 years. The C part has further 2 parts. It says calculate the outstanding balance at the end of 6 years. Same thing. So far, what do we know? This is C first part. So we know that our present value is 23110.12. This is what Oscar borrowed. We know that every quarter Oscar is paying negative 933.62. Every quarter is paying that. What we need to find, what is going to be the future value after 6 years? Again, pretty straightforward. So N in this case would be for 6 years. So 4 times 6, which is 24. I will be same, the percentage of interest rate, which is 6.55. Present value is going to be this that we have found from our previous answers. It's going to be 23110.12. Remember, it's going to be positive because it's cash inflow. On the contrary, the PMT is going to be negative, the regular repayments, because it is outflow. And the future value is what we need to find after 6 years, which is 0. Now, how will we know that it's been calculated after 6 years? Because n we have taken as 24. Before we took n as 32, and we know that future value is going to be 0 after 8 years. So this is something you need to be very, very cautious. And you need to know that what variable, what value you're going to put in these. And that's the whole thing, basically. That's a summary of this whole exercise. To understand that how you're going to manipulate each variable depending upon different situations. And P over Y and C over Y are going to be 4 because these are quarterly payments. So everything is in quarter and everything goes like quarterly. So let's try to see what we get for our future value. Now, our N in this case is going to be 24. Our I is going to be 6.55, same. Present value is going to be the same. Our PMT is going to be the same. FV is what we need to find. And P over Y and everything remains the same. So we'll find the future value here. And future value turns out to be 6947.33. The future value is found as negative $6947.33. The negative sign shows that this is payable value of the loan after 6 years, or the outstanding. So the outstanding balance after 6 years for Oscar is going to be $6947.33. The second part says at the end of the 6th year, Oscar pays a lump sum of $3,000 of the loan. So after 6 years, Oscar settles $3,000 of the remaining balance. Assuming his repayments remain the same, how much Oscar will repay the loan? How sooner Oscar will repay the loan? So let's try to understand this. This was another layer of complexity in this question. So what do we know so far? Let's see. So far we know that the present value of the loan was 23110.12. We know that Oscar has been paying every quarter an amount of 933.62 in negative. And after year 6, we know that the future value after 6 means the outstanding is $6947.33. This is a negative. Now what Oscar does is Oscar repays, okay, means pays 3,000 of this amount. Okay, so at year 6 repays it. So this is what Oscar has repaid. So once Oscar has repaid, the remaining amount remains 3947.33. So this is what Oscar has repaid, 3,000, and this is the remaining that's left after year 6. We don't need to discount because now we are standing at year 6. So this is our present value at this point. We are here. So we will just neglect whatever happened in the past. We are here, and we need to find now how much time it will take to repay this amount when Oscar is still continuing to pay the same amount every quarter. Now let's try to see this and understand this. So our n, what is going to be our n? This is what we need to find in this case, that how many quarters will further Oscar need to pay out this particular amount. The interest percentage is going to be the same, which is 6.55. The present value is going to be this value, as discussed. It's going to be 3947.33. So let's assume this is what he has received. It's in positive because think that this is the outstanding that he has, and this is what he's going to use. All right. Now, in terms of PMT, and he's doing the same thing, which is negative 933.62 per quarter, every quarter. Future value is going to be 0 because we need to find after how many years or how many quarters Oscar will pay out the whole loan. And P over Y and C over Y is going to be same, which is 4. Now let's try to find this n using the graphing calculator. Now we need to find n. So I'll keep that 0. I is going to be same, 6.55. The present value, however, is going to change now. It's going to be 3947.33. The PMT is going to be same. The future value, however, is going to be 0. And P or Y and C or Y will be same. So in order to find n, it's going to be 4.417, which means that 4.41 quarters. So we found n as 4.41, which is approximately 5 quarters. So means Oscar will need 5 more quarters to pay out the loan. So already, if you go back to this timeline, we know that 6 years plus 5 more quarters Oscar need. So means what Oscar need is to pay out the whole loan is 6 years, that has been already there, plus 5 quarters. We know that in 1 year we have 4 quarters, so you can say 7 years and 1 quarter. So whereas before, Oscar was paying out the loan in 8 years. So we know that Oscar will be paying off the loan 3 quarters earlier. This is what Oscar is saving. Because see, 7 years and here it's doing 8 years. So we know that if I want to convert this into 7 years format, so it's 7 years plus 4 more quarters for a year. So 7 goes out. So we know that Oscar is saving 3 quarters or paying out the loan 3 quarters earlier than before if he pays 3,000 lump sum amount at year 6. So if you notice, this whole exercise was all about working your way through the financial calculator, and the variables are all same. It's about playing with each variable, trying to find one particular variable and trying to extract the information from other variables using the question. If you have any doubts regarding this question, please post them in the comments and we will try to address them. Please also note, whether you're using TI Inspire or TI-84 or any other graphing calculator, the process is going to be the same. The variables are going to be the same. Thank you.